A very good morning to all of you. Very good morning. Welcome to Super Coaching by Testbook IAS. This is Venkatesh, your faculty for geography, and in this session, we'll be discussing about a very important topic, the circulation of air around the world, which we call it as, say, global winds, the permanent winds, the prevailing winds. So, if you see in the basic climatological concepts, you should have known by now that you see there is insolation received on the Earth's surface, there is insolation received on the Earth's surface. This insolation is the basis of temperature, okay. So, insolation, temperature. This temperature further is the reason for a differentiation of pressure. For example, when you talk about insolation, the energy received from the sun, does that vary? Definitely yes. Because it varies, the heat received on the Earth's surface is changing, and because of which the degree of heat, which is the temperature, is also varying. So, we have different places having different temperatures. As we have different temperatures, the pressure is different. As the pressure is different, then you have the winds. Which are different. Because of variations in temperature, the pressure, we have variations of wind. So, our learnings today, the global wind systems, I would say that it is a product of these things. So, with this, if you see the circulation around the world, the circulation of air around the world, you will find the globe, on the globe you have wind systems like the trade winds, which are in the tropical part, the westerlies in the temperate region, and the polar easterlies in the polar regions. So, it is in both the latitudes, in both the hemispheres, that is both southern hemisphere and northern hemisphere respectively. You will find all these wind systems. We will discuss about all these things as we move forward. I hope you are all able to follow this. Right. So, if you see this, now what is the significance of winds for you? How do they have an impact on life on us? Anyone? How do these winds will have an impact on life for us? Why are you learning this topic? Anyone can say that? Why are we learning? Yes, put it in the comment section. Yeah, I see some of you are responding there. Hello. A very good morning to all of you. I hope I am audible to you. Yes, good. Yeah. So, what are the global winds? How do they have an impact? They have an impact on us in terms of what? Rainfall. See, for rainfall to occur, we need to have moisture. Moisture is taken care by temperature, but that moisture is dragged towards the landmass at different places by winds. So, you have moisture from the oceans. That moisture from the oceans is is dragged by the winds towards the land. So, it is the winds which carry the moisture and bring onto the land. So, we have monsoons in India, right. So, how do you get monsoons? The southwest monsoon. So, we have the moisture from the Arabian Sea and the Bay of Bengal entering into India at different corners of India, isn't it? So, that is the prime significance. Occasionally, they also bring some kind of storms, say like cyclones, okay, because cyclone is a local level system. They also bring that. So, definitely climatological phenomena, they are having a huge role to play in terms of life around certain places. There is no debate about that. So, they are a huge role to play. Even the deserts, why certain deserts are located at certain parts of the world is because of the winds. Moving forward. Now, if you see the world map, you can see the winds in this way. Okay. You can see here around the equator, this is the tropical areas. The wind system which is occupying is the trade wind. You can see the trade winds. And around the mid latitude areas, you can see here this one, you will find the something like westerlies, and in the polar region we have something like the polar easterlies. And here you find the westerlies. These are the three varieties of the global winds. Why they are called as global winds? Why? Anyone? Why they are called as global winds? Anyone? Why they are called as global winds? So if you see the classification of winds, we can divide the winds from three levels. Say for example, permanent winds, seasonal winds, and local winds. So you can classify the winds in three ways: permanent, seasonal, local. The winds which are permanent at that part of the respective latitude, which prevail at a certain respective latitude, that is called prevailing winds. All these are one and the same, permanent, prevailing and all. See, what is permanent? The wind systems which blow throughout the year. It is not like they have a break. Okay, now we will have a wind, tomorrow Sunday we will take a holiday. No, they are permanent throughout the year, right? They are prevailing at that respective latitude, like tropical regions, like temperate regions, like in the polar winds prevailing. They impact every part of that particular globe. Hence, they are called as global winds. So, you can talk about global winds, you can talk about prevailing winds, you can talk about the permanent winds. So, all these are one and the same. Then you have seasonal winds, which blow at a particular season, not every time. For example, like monsoon. Then you have a local level, say local winds. Say in a coastal region, we have a concept called land and sea breeze. Sea breeze in the coastal regions. So, land and the sea breeze in the coastal regions. That is also one thing. You can have something like, there is a very unique rain by name Sirocco. It is a local wind in the African region, very unique. That is there. So, you have the permanent winds, seasonal winds and the local winds. This is the classification of winds. Then what are global winds? As I told you, the winds which blow throughout the year, permanently, okay, throughout the year, all across the globe, at their prevailing latitudes is what is called it as global wind. So, we have three varieties of global winds, as I have told you. You can see the trade winds in the both the hemispheres. You can see the westerlies here, and here you will be finding the polar easterlies. This is the polar easterlies. So, they are the ones which are blowing continuously throughout the year at that respective latitudes. Then, what are the forces which impact it? How do they move? Let us discuss that. So, when you see a wind, they are always impacted by multiple things. One of the first things they are impacted is the pressure gradient force. Forces which impact wind, the first force we can have is the pressure gradient force. You all know the pressure distribution of the world. What is the average pressure distribution of the world? If you see the average, the general average, for example, the air around you, the air around me, in general, the average pressure condition is somewhere around 1013.4 millibars. Okay, excuse me, yeah, 1013.4 millibars. If you see that is the average of 1013.4 millibars, you will find that there is a difference across. Sometimes the pressure increases, sometimes the pressure decreases. Where it increases, as you can see here, you see 1030, 18 and all, this is a high pressure area now. What is this? Now this is a high pressure area. And when compared with this, this is a low pressure area. Now what is happening? There is a difference of pressure which is created. That is what you call it as the pressure gradient. What do you mean by gradient here? Gradient means what? The one where there is a slope, where there is a difference, something like that, right? So pressure gradient force. The more the pressure gradient, the more the faster wind systems. For example, you all have seen a cyclone, isn't it? Cyclone winds sometimes can cross even 100 kilometers per hour. Say the recent cyclone which affected southern India, Andhra Pradesh and especially Tamil Nadu, Chennai, Migjom, the wind speed is around 110 kilometers per hour, 110. There are some severe cyclones where the wind speeds gathers around more than 200 kilometers per hour. More than 200 kilometers per hour is almost like a Formula 1 car, right? So why do you think that you have such much force? The low pressure of a cyclone is much more severe. It can be coming to even around 940, 960, sometimes even 920, occasionally even nearer to 900 as well. Very, very rare, but usually you can say 960, 980 is the norm. But 940, 920, 900, occasionally a cyclone can intensify to that level. When it intensifies, this gradient becomes very high. See, when you compare the distance between Delhi and Agra, when you compare the distance say between from say Kanyakumari, that is the southern tip of India, the mainland India, from Kanyakumari to say Agra, is the distance far or more? Definitely it is far. But when you compare that with respect to distance from Kanyakumari to say Srinagar, I would say Agra is relatively not far. I cannot say it is nearer, relatively not far, right? That's what the difference is. So geography is all about relativity. One of the relativity you can find is the pressure gradient force. High pressure, low pressure, highest pressure, lowest pressure. There is high pressure, there is low pressure. Look at the gradient now, highest pressure, lowest pressure. Look at the gradient now, huge is there, no? There is huge difference, no? That huge difference is what you talk about a cyclone. Then the wind speed will rush, will come quickly. So when you have that quick difference, that is where the pressure gradient force is there. This is number one, pressure gradient force. Number two, you will find that it is impacted by something called as Coriolis force. What is that? Coriolis force. By the way, what is Coriolis force? Rather, it is not a force. It is an effect of rotation of the earth. What is that? Rather, it is a effect. It is an effect of what? Rotation of earth. Imagine that imagine that we have went to a merry-go-round. Merry-go-round. I think when you go to any fair, the local fairs in India, in a village or even in a town, you have a merry-go-rounds where you have the horses, the kids are sitting on the horses and they are moving across the center like that, right? Let's play a game. Let's play a game. You have a ball in your hands, you are at the center of that merry-go-round, and say your friend or your brother or a sister is sitting on the horse and they are going around it, right? Imagine the scenario. So a naughty boy, somebody like me, maybe similar to me, I have a ball in my hand, I wanted to throw to my sister or a brother or my friend, whoever it is. So what I'll do? Imagine I'm here, I'm at the center of that merry-go-round, and they are here, exactly so pointing to my camera here, right? So imagine that there. Now, as they are moving or they are static? They are moving, no? So if they are moving, imagine I throw the ball, exactly where are they located now? By the time the ball reaches, as they are moving, they will be located here. I will hit somebody, they will hit me. Right. So what do I need to consider? I need to consider that they are moving. So what happens? I need to throw that. So imagine they are here and the moving is like this. Then I have to throw the ball here, and by the time the ball reaches, they would come here like this. Exactly. Right? That is the thing. So that is what is the effect. You can see here the diagrammatic representation. So as this is moving, you can see that they rotate like this. Okay, depending on the rotation. Similarly, you can see that. Imagine that from the global point of view, from the world point of view, the earth is rotating from west to east. As the earth rotates from west to east, you will definitely find that any freely moving body, if you see from the north pole, as you can see in this pictorial representation, look at this red color, it is deflecting. Now you see here, imagine from the north pole, you are supposed to move straight, but it is being deflecting like this, no? So that is the impact of Coriolis force. What does Coriolis force do? Any freely moving body will deflect towards the right in the northern hemisphere. What does Coriolis force do? Will deflect anything towards the right in the northern hemisphere and deflects towards left in the southern hemisphere. Deflect towards right in the north, deflect towards left in the southern hemisphere. That is the impact of Coriolis force. Is it a force? No, it is an effect of rotation of the earth. As the earth rotates west to east, see from north pole and then see from south pole. Everything will deflect towards right in the north, left in the south. One important thing you need to remember is they are absent at equator. Absent at equator, and they keep on increasing as you move towards pole. Increases as you move towards poles. So they are highest at the polar regions because that is where the maximum impact is there. Imagine that merry-go-round. Imagine it's a smaller one. The deflection would be less. Imagine it's a bigger one and the force of the speed of the rotation. Then you have to throw it quickly, throw it fast. No, that is the impact. Okay. So if you see this, as I was showing you here, all the wind systems, say all the oceanic currents, any freely moving bodies like winds, ocean currents, they will be deflected towards right in the north and towards left in the south. Also, let me give you another, I hope my explanation is clearer to you, you are understanding that. I will give you another example for you to make understand. Now, you take any kind of a chopping pad, something that, or what, any kind of a rotational thing. Take a piece of paper. You take a piece of paper here. Imagine I have a piece of paper here, and there is a scale on it. Okay. Imagine this is the scale. Okay, leave the phone here. Imagine there is something underneath me here. There is a paper, and this is the scale. Now, when I draw it like this, there is a straight line I am drawing. It looks straight, but make the paper rotate. Okay, maybe somebody help if they are rotating. What can do? As I now draw a straight line, what will happen? I have drawn a straight line, but it is rotate, no? Because of the rotation, there will be deflection, no? That is the impact of Coriolis force. So that is a thing. So because of the rotation of the earth, as the earth rotates, as you move, because of the impact of the Coriolis force, because of the impact of the rotation of the earth, you will be either deflecting towards the right in the north or left in the southern hemisphere. This is what you need to remember. Okay? Right in the north and left in the southern hemisphere. Now, if you see the global map, Okay. Imagine this is the global map. Now we all know that winds move from high pressure to low pressure, isn't it? Do you agree with this? Do you agree with the idea that winds move from high pressure to low pressure? Yes. Now let us say categorical representation. If you see the global pressure distribution of the world. By the way, if you are liking the explanation and all, please like the video, share it to your friends so that they also will be able to benefit from the topic. Also, you also try to subscribe to this channel so that any new videos you will be notified very quickly, right? So if you see this, if you see the pressure distribution of the world, there is a equatorial low pressure belt here. There is a subtropical high pressure belt here. There is a subpolar low pressure belt here and polar high along the polar regions. This is what we know about the pressure belts, isn't it? Now what happens? Generally winds move from high pressure to low pressure. So a subtropical high, from there wind is supposed to move towards low pressure like this, okay? High pressure to low pressure. This is number one. Number two, because of Coriolis force, they deflect towards right in the north, left in the south. Okay, let me draw this diagram again. Okay, so for a while, let me take the base. Imagine this is the equatorial low pressure belt. Okay, equatorial low pressure belt around the equator. This is the one you have something called as subtropical high pressure belt. This is where you find subpolar low pressure belt, and here you will find polar high pressure belt. Imagine this is the thing, okay. Now what we supposed to know is winds move from high pressure to low pressure. So there is a wind which moves from here to here, high pressure to low pressure. Similarly, high pressure to low pressure like this. But because of Coriolis force, they are deflected towards the right. Now imagine in the northern hemisphere, this is the path. Okay, from here they are moving like this. See, from here if you see it if you put it in a horizontal way, this is subtropical high pressure belt, and nearer to the camera equatorial low pressure belt. So winds supposed to move from high pressure to low pressure like this, but they are deflected towards which side? Towards right in the north. So because they are deflected towards right in the northern hemisphere, they are supposed to move like this, but because of the rotation of the earth, you will feel like this, right? So this is the rotation. From my side you see it, right? Rotation deflecting towards the right. So because of this, now any freely moving body, what will happen? It deflect towards the right in the northern hemisphere. So that is where they attain the speed, or they attain the direction of what? Trade winds attain the direction here something as northeast. Okay, let me take a lighter color. Okay, northeast trade. Similarly, from the southern hemisphere, imagine there is this is the subtropical high pressure belt, the pressure belt, and the winds move from high pressure to low pressure. Winds move from high pressure to low pressure. Then in the southern hemisphere, winds deflect towards their left in the southern hemisphere. This is their left. So instead of deflecting now towards their left, this is the original path. As they travel, the destination is low pressure only. As they travel, they will deflect towards their left. So in that way, we can say that. Now look at the direction. Now see it from the north corners: north, south, east, west. How did we draw these trade winds here? I have drawn like this. So where is their origin? Northeast. That way they are called as what? Northeast trade winds. Look at how did I draw here in the southern hemisphere. I have drawn like this. So the origin is southeast. That's why these are called as what? Southeast trade winds. Similarly, the westerlies you have. Westerlies, once again here also winds move from high pressure to low pressure. High pressure to low pressure. Because of Coriolis force, they deflect towards the right in the north. Right in the north. But they are away from the equator now. The deflection would be slightly higher. Say here if I had drawn around 20 degrees, 30 degrees, here you will draw 45 degrees tilt. So the deflection would be now something like this. You see here, the deflection would be like this. See, this is the original deflection. Look at the amount of originality, or what will you say? If the first one I told you, pressure gradient force, pressure gradient, only because of the pressure gradient they have to move in a straight line. Because they are rotating, they have to move like this, right? So that is the impact of a wind. That is the impact, sorry, that is the impact of the Coriolis force on the wind. So this is the thing. So this is what you call it as westerlies. I hope you are all able to follow this. Hope it is clearer to you, right? Now, when you see from this impact across the globe, let me show you the globe. You see here, look at how did we draw the northeast trade winds? We have drawn like this. How did you draw the southeast trade winds? You have drawn like this. So this is the basic distribution. Then, when you see that, now let us understand how do the winds blow. So imagine there is Africa. Okay, let me draw Africa map. This is around the equator. Now, when you have the trade winds which are blowing like this, what will happen? They will give rainfall to the eastern side of the continent. Now, you see they are coming from ocean to the land. Here, this portion, you have very, very decent rainfall. Whereas, the same wind as it is blowing, you look at here now, what is happening? There is no wind which is coming from the, say, from the Atlantic Ocean towards the west coast of Africa. No wind like this. Because there is no wind here, and here you will find deserts. Deserts. So, if you take any continent, so for easy understanding, if you wanted to take, let me draw you, make you a easy understanding. Imagine this is the equator. Okay. Now imagine. Okay. So imagine this is the equator line. Okay. This is the Tropic of Cancer, say, or this is the 30 degrees north latitude. This is 30 degrees south latitude. This is an equator. Now, how do the winds are blowing? The winds which I told you in the tropical part, they are called as what? Trade winds. Why they are called trade, we will discuss later. So if you see, the winds are supposed to travel like this. Okay. Imagine this white color one is called a continent, and the surrounding things is an ocean. Now what happens as they travel like this? What happens? You can clearly see that within the tropical part, when trade winds travel, see, moisture is a product of heat, right, and also the availability, both. At the equator, because of more heat, there is always more rainfall, convectional rainfall, isn't it? Convectional rainfall. Yes, Gitanjali. Good afternoon. Hope you are all doing well. You have joined late, I guess. Anyhow, it's okay. Good afternoon. Hope you are able to understand. Coming back to the topic, trade winds. As they are moving like this, now what is happening? Nearer to the equator, you will have decent rainfall because of the moisture availability at the equator itself. But as you move away from the equator, the trade winds will determine which side they will give rainfall, which side they don't give rainfall. If you see from the eastern part, imagine the eastern part here, they are coming from the ocean to the land, they give rainfall. Whereas if you see on the western side, you see here, away from the equator, they are coming from land. There is not much amount of availability of moisture. The winds are dry. So trade winds are having moisture in the eastern side, doesn't give and not having any moisture on the western side of a continent. Because of that, they give rainfall to the eastern side, decent rainfall. On the western side of a continent, you always find the deserts. The deserts. Here there is a desert. Here there is a desert. You can see a typical desert here. What is the desert name here, which we call it as? The Namibian desert. Namibian desert. And similarly, here you can see that this is the desert of the Great Saharan Desert. Why do you think Saharan Desert existed here? Because the wind which is blowing here, the northeast trade winds blow like this. As they are blowing like this, there is no wind which is coming from the Atlantic Ocean into like this. There is no such wind here. Okay, you don't find like this. Because of that, what is happening? You are finding that there is a great desert which is formed. So now we have understood why deserts are formed only at certain latitudes. See this picture. Identify all the hot deserts. Homework for you. Open your atlases. Check all the hot deserts. If you see all the hot deserts, say all the hot deserts, so you can see here, this is the desert of Mojave or the Mojave desert or the Sonoran desert or the Mexican desert. You can see the same latitude, you can find the Sahara, Arabian desert, the Thar desert of India. Similarly, in the southern hemisphere, here you will find Atacama desert, that's now I told you the Namibian desert, and as well as the sandy desert, the great sandy desert or the great Australian desert, which we call it as. All the deserts are located within the latitudes of, or all the deserts are located within the latitudes of 20 to 35 degrees on western side of the continent. The reason of western side is because of the wind. Why 20 to 35 latitude? There is a different topic. We will discuss that later. Now itself, just 5 after certain minutes. So this is the impact. I hope you are able to clear it, you are able to understand it. So the reason for a desert formation. What is the reason for a desert formation? Because of the trade winds. Now if you see, imagine this is the equator, or sorry, imagine this is the equator line, 0 degrees line. This is where, this is 30 degrees line, northern hemisphere, 60 degrees line, southern hemisphere, say 90 degrees line, northern hemisphere. So this is, if you see in the globe, similarly here 30 degrees south, 60 degrees south, 90 degrees south, imagine. Now what happens at the equator? This is a low pressure area, and at the equator fairly you find a decent amount of temperatures, because of which air expands, there is convection. So the air will rise here. What will happen to the air? It will rise. Because it is at the equator, there is more heat, the air is rising more. That is the reason why you will find that the tropopause, the line differentiating or the line differentiating between the layers of atmosphere, stratosphere and troposphere. Tropopause is around 18 kilometers at the equator, 18 kilometers. The average is only 13, whereas at the poles they are only 8 kilometers, because of which they are high. Now what happens? It is not like this air, whatever is rising, it is moving into the outer space, no. They have to fall down. So, after ending, they take a deflection in the upper atmosphere and they slowly sink. What is happening? They are slowly sinking. Slowly sink. Now, what is happening? The wind which has risen from the equator is sinking here. Now, as it is sinking here, what happens here? This is a zone of high pressure. The wind is getting, the latitudes are getting more air from the upper atmosphere and the winds are descending. Because of this wind descendance, when there is concentration of air, what will happen here? You will find high pressure. This is the high pressure. At the ground level, you find that there is a difference from high pressure to low pressure, because of which winds are moving, which we are calling it as the trade wind. You see this? Winds are moving, trade wind. Because of this complete circulation, we call this as what? Hadley cell. So, the low pressure belt, the air rising, giving decent amount of cumulonimbus clouds, rainfall, thunderstorms at the equator, air rising into the upper atmosphere, after that descending into the high pressure area. Now, here you see wind is descending, where is concentration of air at the ground, the air is falling down, concentration of air, there is high pressure. When the winds are descending, they descend around the latitudes of say around 20 degrees to 30 degrees north. So, all the hot deserts are located between these three things, because between these latitudes of 20 and 30, because there is wind descendance. As there is wind descendance, what will happen? There is no opportunity for the air to rise. That's why all the hot deserts are located within the same latitudes. On the western side of the continent is because of the trade wind, but within the latitudes of 20 to 35 degrees. So, hot deserts, the latitudes of 20 to 35 degrees, both latitudes, north and south latitudes respectively. Respectively is very important here. If you say 20 degrees north and 35 degrees south, then you are creating a new world. That is not the reason. Okay, 20 and 35 degrees north latitudes, or 20 and 35 degrees south latitudes. It cannot be together, or one is of one hemisphere, other hemisphere. No, then this is a new world. Okay. So, here around 20 to 35 degrees you will find the wind descendance. So, no opportunity for the air to rise, that is why no rainfall, that is why they are called as a desert. See, for rainfall to occur, there has to be moisture in the air. That moisture is not taken care by trade wind, and this moisture, if at all, even if any moisture exists, it has to be taken to greater heights in the atmosphere for it to cool down, clouds to form, and then to rainfall to occur. Even that is not happening, isn't it? That is the reason why you will find deserts are found only in the latitudes of 20 to 35. And there you are also finding that this impact is there. I hope you are able to follow this. Because of this phenomena, you are finding this as a base. Okay. So, hot desert 20 to 35 and trade winds does not give rainfall to western side of the continent, or in other words, technical word you can say, trade winds become offshore. Offshore means what? Coming from the land without any moisture, trade winds are dry. That is what you say. So, this is about the global circulation. So, if you see the trade winds, what do? They blow from subtropical high pressure belt to to equatorial low pressure belt. Subtropical high pressure belt to equatorial low pressure belt. They are called as northeast trade wind in the northern hemisphere. In the northern hemisphere, they are called as southeast trade winds in the southern hemisphere. And why they are called as trade winds? Because trade is derived from a word called as constant or consistent or regular path. That is the reason why they are called so. Okay, some of the textbooks have said that trade winds is because they helped the traders. No, they have helped the traders, that is right, but that is not the reason why they are called as trade winds. There is a difference in both. Okay, they help the merchants to travel the as along the winds. They are helping the merchants in terms of travel in the ancient days. Of course, now we have everything is mechanized, no, not needed. Whereas in the past that was not the case. So that is the idea. So you have seen that this is the impact of the trade winds, and what is the most important thing you have to need to? We have to remember they give rainfall to the eastern side of the continent, and that doesn't give rainfall to the western side, eastern side, and on the western side no rainfall. Eastern side of continent, rainfall. Rainfall on eastern side. Western side, no rainfall. This is about the trade winds. Now you see the world map. You see here. You see, there is a reason why certain areas are getting more rain than others. You can see here, this area. This what do you say? Let me show you a different color. Yeah, this area more rainfall, whereas this area no rainfall. There is a reason. Similarly, around the world there is a reason. So trade winds control the weather, having a decent flow of impact on the weather in the northern latitude. That is the impact of the trade winds. I hope you are able to follow this. Huh? Right. And one more thing I forgot to explain to you. The winds are also impacted by frictional force. Any wind is also impacted by friction. What is friction? It is created by the earth is not a simple surface, no. It has mountains, it has plateaus, it has cities, it has so many things. So the atmosphere is having multiple things. So when winds are blowing, they blow consistently above a certain height because there is no obstructions. Whereas nearer to the ground, they are always obstructed by something from the surface features of the earth like trees, mountains and all. So friction is very nearer to the surface, and that will slow down the speed of the wind. That will slow down. Imagine wind speed, winds like subtropical winds moving in the ocean. You don't find much of the pollution, no. You will not find an industry located in the ocean, no. Most of the industries are located on the land. Of course, you do find pollution in the ocean as well, but air pollution is relatively lesser. So air is free from dust particles and all. The air moves quickly in the ocean, whereas it moves very slow in the land. That is the impact. Also, within the land, you can see that nearer to the surface, the frictional force is more, so wind speed is less. Whereas as you move above the surface, a decent height, say around 1500 meters, something like that, after 1-2 kilometers, you will find that the frictional force is becoming much more lesser, because of which wind speed becomes faster. That is the impact of frictional force. Hope you all have understood this topic well, right? The trade winds and all. Remaining things about the winds we will discuss at some other time. Do like this channel, like this video if you have liked it, share it to your friends. Also comment about any doubts you have. I am here to help you. Also, don't forget to subscribing to the channel, because this subscribing will help you to give notifications about more such videos which are coming up exclusively for you in the English medium. Okay. Until then, have a safe time with yourself. Be safe. Try to prepare well. Enjoy the preparation process completely, and have a good time. Happy preparation to all of you. Happy learnings. Thank you for watching. This is your faculty of geography, Venkatesh, signing off.